Right, I cannot fully tell you how your nervous system decides how much force your muscles produce, and I study this stuff. That's actually why I'm starting a research degree in September to go and find out. If you followed this page for a while, you'll know that most of what I post already lives in this space. Motor unit recruitment, rate coding, EMG, fatigue mechanisms, the neural basis of strength. And that has not been accidental. The content has been building toward this for a while, and now there's a formal version of it. From September, I'm starting a Masters by Research at the University of Birmingham in neurophysiology of exercise science. My research focuses on the neural control of human movement and exercise performance, specifically how motor unit behaviour, central motor drive and afferent feedback influence force production, fatigue and muscular adaptation during exercise. And I'm going to be documenting what I learn here in the same way I've been explaining exercise science for the last couple of years. To give you a sense of what that actually involves, when you contract a muscle, groups of neurons in your spinal cord fire electrical signals down to the muscle fibres they control. The number of those neurons recruited and the rate at which they fire determines your force output. That much we understand reasonably well. What gets more complicated is what happens as effort continues. The firing pattern starts to change, the rate drops, and crucially, the muscle itself is sending signals back up to the spinal cord and brain, sensory feedback from receptors that respond to mechanical stress and metabolite accumulation that actively reduce the motor drive being sent down. Some of the fatigue you experience is happening in the muscle, some is happening at the spinal cord, and some originates from the motor cortex itself. Separating those contributions, measuring them independently, and understanding how they interact with training and adaptation, that is exercise neurophysiology. And that is what I genuinely do not have a complete answer to yet, which is the whole point. The tools we use to study this include high-density surface EMG with motor unit decomposition, which lets us record the activity of individual motor neurons through the skin without needles. And we also have transcranial magnetic stimulation, or TMS, which uses a brief magnetic pulse to probe the excitability of the motor cortex during and after exercise. Peripheral nerve stimulation, which bypasses voluntary effort entirely to measure what the muscle itself can produce, and voluntary activation techniques that let us quantify exactly how much of a muscle's force capacity the nervous system is actually accessing. These are research-grade methods that are giving us a window into the neural control of movement that simply did not exist 15 years ago. I'll be explaining all of them properly in upcoming videos. Now, this is not a pivot, it is the continuation of a direction this content has been heading a long time. The same approach, explain mechanisms properly, be honest about what the evidence does and doesn't show, and don't overclaim, but now anchored in the specific research questions my lab is actually working on.